the industrial automation, very basic concept. And also we have done some simulation program, and we have done it also. So in order to start this training, let us go through quickly recap few things, so that we will get understand the basic concept quickly, and then we move to the actual programming, right? So I'm going to share my my window. So in case in between, if it get disconnected, let me know, right? So hope my window should be available to everyone. Right. Is my window available to everyone? Anyone say okay, so that like I can proceed. Guys, is my desktop available to everyone, visible to everyone? Guys, is my desktop available to everyone? You can say, you can you can say, anyone say yes. Waiting for your confirmation, boy. Like somebody has to confirm.
Sir.
Yes. Okay. All right. Fine. It's very hard to get S from you boys. Right. Fine. I'm trying to proceed further. Right. So all of you aware that like the industrial automation, what we have learned in the last time, like basically the industrial automations evolved by the three concepts. One is the production, because all the company, they want to make a more production. With the manual production is going to be less. So people wanted to increase the productivity. So they were looking for a machine which can work continuously based on some predefined instructions, so that they can increase the production. So that is the production was the first concept, and then the quality. So the man cannot do the perfect quality all the time. Yes, obviously he can do, but all the time doing the quality may not be possible. So whereas with the machines, they will be able to produce the multiple component with the same quality all the time. So the quality has become one of the important factor in the industry. And then finally safety, because safety was one of the prime concept when you're doing the mission critical application, like a welding or cutting, this kind of operation when you're doing, obviously man can do very carefully, but he cannot do perfectly all the time. And also, even if it happens, it's going to be a damage to the human, whereas the machine, they can tolerate. So they can do perfect always. They don't do a mistake because the program is pre-fixed. And even if they get affected, there is no loss, human loss. So that way, still we are in a better shape. So basically, the PLC evolved because of these three concepts. They want to do a more production. They want to do the better quality, and they want to get the quality and more production with the safest way. So for these three, if you need to really achieve, going ahead with the automation is the best solution. That's how the evaluation has come up. And just to recap our the previous year messages, like where exactly the automations are used very high level is pharma industries, like wherever the pharmaceutical bulk drug, you know, right now, like with the corona, like how the drugs all has become a more criticality because all the drugs running out on every day basis. So this are like and also you remember like everybody is wearing a mask. See, the mask production is like if you are doing manually, you cannot fulfill the Indian population of 1.3 billion. So the machines, they do started doing the production. That's why we are like now we are all getting the enough stock. So these are all done by the pharma industries. Like they produced a more kind of the mask and all the production. These are all like automated. So the machines does per second like a 3 or 4 the numbers they are producing. That's how the production increase. That's why we are all comfortable now. So basically, the automation plays a major role in the pharma industries, and also the oil and gas industries, where we get the petrol, where we get the diesel, and we get the gasoline, gas. So these are all like extracted from the ground and then purified and separated, and the separated one is getting transported to the distribution location. All of them is controlled by the PLC control system. And so generally, like the in a current in the advanced level of the very initially people had some kind of a programming software which you have to do manually many multiple things, and later when things has come up, slowly the programming software become a very comfortable way, very easiest way. Just you need to drag and drop and connect the few components. And then you get through with the logic. So basically what you have to know is you have to know what is your requirement clearly. When your requirement is clearly known, then it is nothing. It's just you need to drag few components, connect it the way how you want, and then you get the result, right? And anyway, like now the multiple software has come up with a simulation facility where before you download this software into the controller, you can test it in the computer, make sure your developed software is working as expected, and then once you feel comfortable, then you can put this software into the PLC. That's how like the current software is available. And the same that's what we are going to do also. So what we are going to do, I hope everyone has the laptop. That's what I presume, but I am not sure how many of you have the computer. If you have a computer, it doesn't require like a big software. We are going to get you the very small software which can do all the functionality. But right now, if you do not have it, maybe next tomorrow, if you can get your PC from somebody else temporarily for the next 5 days, then you can able to work along with me, and then you will be able to practice yourself, right? So that will give you more confident on the programming part. Otherwise, like you will be seeing the program what I'm doing, but later stage it may vanish, right? So whoever having the PLC, it is the computer, it is well and good, because it's easy. In case if you do not have it, either you can combine with somebody, or you can try to get from somebody else for temporary basis, just for 5 days. And once you worked, and then you can hand out them, so that way at least you get a better exposure to the programming software, right? Right. So, so each the components are like a AND gate, OR gate, NOT gate, flip flop, timer, counter. These are all the various components which every PLC has its own, and just we need to connect it to get it right. So we will go one by one. This is just a recap of what we have learned in the last time. And the only thing is, like, we want to address to you like a microprocessor based. Still, the microprocessor based boards are still active, but only thing is like those are like for a few small applications, not the very big application. Because when the very big application comes, the microprocessor based programming is going to be a tough, because you need to write a C coding, and when a complex logic comes, it may be little hard to implement, and all, not only the implementation is hard, after you implement, the person reading the program also little difficult. Whereas in the PLC, it's like a easy drag and drop configuration. So doing program, even if it goes a complex level, it is easy to do it. And when the person who is reviewing the logic also easily he can understand, and he can adapt for the industrial environment. So that is why like people do not go with the microprocessor based control in in the industry. Rather, all of them goes with the PLC based control, because it's an easy implementation, drag and drop configuration, and if anything troubleshooting is there, it's easy to view. Whereas the microprocessor based, you need a special person, and also the guy who has written the logic, he has to be always there. But whereas in industry, it is not that way. Industry today, somebody will be there, and tomorrow somebody else come and join again. So everything should be in interoperable, like meaning like when one person is working on it, when he leave, the other person has to come and work in the same level. It should not be like something like only the guy who develops supposed to be there. That is why the industry normally they used to prefer the PLC based control, not the microprocessor based control, right? Right. So these are all the like a various list, like oil and gas, refineries, chemical plants, pharma plants, engineering and manufacturing company, electrical equipment manufacturing company, textile companies, water treatment plants, power plants, and so multiple things are there. So last week I went to Andhra Pradesh, like near Guntur. I don't know what is the name of it. Like near Guntur, there is a NSL Textiles. So NSL Textile I visited because they had some problem. So we visited a NSL Textiles, and we offered some solution for their automation, and then they want to see the centralized all equipment. They want to see it. It was a really very big company. So it looks like you have in Andhra Pradesh, you have a multiple textile industries. Also you have the cement industries and pharma too. So multiple industries are there, but only you have to explore, so that like when you come out, you can look for an opportunity, right? So before we go into the any logic understanding, let us do the quick understanding of how the field instruments are connected to the PLC. So this is just to recap you to understand what we are trying to do, right? So so basically, like if you look at the bottom, very bottom, if you see, this is a field. The field is nothing but in the plant side. In the plant side, when you walk down, you will see the transmitters. The transmitters is like the measuring instruments. They take the field measurements. We will see, like next slide, we will see what is transmitter and everything. We have already seen, but just we will recap it. So this is to give you the overall idea what we are going to do now. So basically the transmitters are there. They, like in the bottom leftmost, they normally measure the field, like for example temperature, pressure level, all the measurements, they measure, they send the signal in terms of 4 to 20 milliamps, because it's a that's a current method. Current is used to transfer the signal to the control room. The 4 to 20 milliamps, like 4 milliamps means the engineering value 0, 20 milliamps is engineering value maximum. The engineering value minimum maximum is engineering value 0. For example, if you take a level, engineering value 0 means tank level is 0. Engineering value maximum means 100, because tank level can be 0 to 100%, right? So when a 0% level is there, the transmitter sends a 4 milliamps to the control room, and when the tank level is full, it sends a 20 milliamps to the same cable to the control room. That's how the PLC understand, by looking into the 4 and 20 milliamps, it can understand what is the actual tank level, right? So then if you look at the next component, it's a control valve. This is the analog output. So generally, like if you want to control a level in a tank, or flow in a tank, or pressure in a tank, so this equipment is used. Generally, this gets the signal from the IO card in terms of 420 milliamps to operate up and down, close the valve, open the valve, like in terms of inch by inch, percentage by percentage, meaning 5%, 10%, 20%. So these are all getting operated by the current, again the same current, 4 to 20 milliamps, which comes from the PLC, right? So transmitter, they send the signal to the PLC, and control valve gets the signal from the PLC. It's like a reciprocal, because the instruments, the transmitters are input devices, the control valve is a output device. So this will get a signal from there. We'll see the next slide. Understand well. So basically, when you understand the field instruments, transmitters, and control valves, they are connected to the junction box, and from the junction box, a cable goes to the PLC IO cards. This is the IO cards, and once the IO card means input output card. See, it's like a I/O. I is the input. Obviously, the transmitters are input. O is output. Output card is control valve. So basically, like it's a multi-pair cable, like the cable what you see in between the junction box and the IO card. In that card, you will see a multiple wires inside. So one wire from the transmitter go to the input card. The other wire coming from the control valve go to the output card. That's how it get connected actually, right? So the field instruments connected to the IO card via the junction box, and then the IO cards are connected. You can see here it goes to the CPU. This is the CPU. It's a small card. This is the CPU where you write all the program, and your program resides inside. And then this CPU communicate to the computer, and this computer you can either monitor, or you can change the program and download to the CPU, right? So this is the generally they used to call as a PLC system architecture. So generally like the top one what you see here, the computers, they are for doing the engineering and to operate the plant. Like engineering means if you wanted to they configure the PLC. For example, let us say whenever the tank level is high, you wanted to start the motor. So that configuration you have to do it. So you have to do from the computer, and then after you completing it, you have to send the program to the CPU. So then the CPU start functioning based on what program you wrote it. So for this task, you need a computer with software. That computer with software, what is running? It's called an engineering station, because basically you are doing engineering on the PLC. And the operator station, like generally like once you download the program, when the PLC is operating, the operator wants to monitor like what is the level, what is the pressure, and what is the set point. Like for example, I wanted to maintain a tank level 70%. So who will enter it? Operator only will enter. Operator, how do he enter actually? He enters in a graphical format. It's called a SCADA system, like SCADA, SCADA system, supervisory control and data acquisition system. It's a graphical format. In that graphical format, he used to enter a 70%. So when 70%, that value go to the PLC and CPU get the 70%, and then accordingly it will try to regulate the control valve or pump or whatever and try to maintain that. So all the operation and monitoring will be done by the operator station. So basically two of them are the two different types in the control room. This is a clean room where you have the glass room and everything, where the operator sits and have a look on the monitors. Right, it's a control room. So the field, we know that it is a kind of like open space where you have all the equipments, piping, and all the stuffs are there. And the rack room is the room between the control room and the field room. It's a one building where you have the panel installed with the PLCs, right? The IO cards and PLCs all will be there. That is called a rack room. So basically three portions: field, rack room, and control room. In the rack room, you have the big panels having all the input, output cards, terminations, and CPU. All are put together in a one panel, and you can see everything. Right. So basically, when you say the system architecture, it has got three components: field, rack room, control room. Field is all the instruments will be there. The transmitter, control valves, and multiple instruments are there. Rack room is a PLC and IO cards, and the control room is a engineering station and operator station. Right. This is the overview. If you have the overview, then when you go to the industry, you can easily realize what exactly the people are doing. Right. Now, before we go into the programming part, just we need to understand, which we have seen it already, but just for recapping, just to understand, so that like you will go and do the program without the confusion on the input outputs, right? So the digital inputs, like the digital inputs are like devices which send the field status via on and off signal or high or low signal. Like for example, let us take a pressure switch. The first one is a pressure switch. So normally what they do, the bottom portion, what you see, the brown, like light yellow color. So here normally the thread will be there. So this device, for example, if I need to check the pressure of the vessel, then there it will be installed through this thread. It will go under thread inside, and then this switch has got a settings here. Like you can see, yes, the two settings are there, right? By adjusting these two settings, you can tell when the tank pressure is more than 5 bar. The bar is a 1 unit. Like it's like if you go to the puncturing shop, like where you fill your tires, you can see the guy has got the vessel where you have got the gauge. In some places, you can, if you go to the petrol station, you are seeing a small display where you can see 25, 35, 45 something. He used to change, and then he connect the small the iron piece on your car tire. So basically, the value what you are seeing, that is the pressure for the unit. What you see here in for the Indian standard is PSI, a pounds per square inch. PSI, that's what you see. Next time when you're going, you can see it. Value will be there inside by, you can see PSI, a pounds per square inch, the pressure unit, right? So like a 23, you can, if you set this 23 PSI, if the vessel pressure increases more than 23, then this will give a contact changeover. Like you can see, the contact inside will go off. and when it goes less than that, this will become on. So basically, it act like an on-off switch, like how you are doing on a light in your home. When you switch it on, the light glows. When you switch it off, the light goes off. The same way, when the pressure goes more than the 23 psi, if I set it, then it'll go off. So when it goes off, when I connect my compressor, like that's what they have done. If you go there in the tire filling station, beyond something like a 60 psi or whatever, the compressor stop by itself, because they have a pressure switch, same switch, and they set it for 60 psi. Once the pressure goes more than 60, this will go off. And well, since it is going open, which is off, the compressor will get off. When slowly pressure coming down, 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 when it comes less than 50, then this switch will become close, like how you are switching on, close, it becomes a close. Once it close, the compressor starts. So the pressure switch gets open and close based on what set point you are given. So by using that, they start the compressor, stop the compressor, because it is changing the contact. So this pressure switch send a signal to the PLC system by closing, opening the contact. By closing the contact, it is telling to the PLC that the tank in a pressure is low, and then you have a program like to start the motor, compressor, or whatever. You have a program inside again. So when the pressure goes less, when the pressure goes higher, it opens. Once it opens, PLC understand the pressure on the tank is high, and then it uses that signal and it starts stop the compressor. Not only compressor, it does a lot of activities like whatever the way you program, right? Like the same thing, like the push button stop switch. Like when I push it, it stops, and when I release it, it closes. Toggle switch, like when I make it up, it will be on, down, it will be off. And sector switch, if I put in a right side, it will be on, and if I put it a straight, it will go off. And level switch, this level switch, like you can see the bottom white color, as long as this white color is in the bottom, this switch will give a close contact. That means tank level, like when you put this in a tank, in your house overhead tank, if there is no level, water won't be there. So this float, what do you see here, the white color one, it will be in the bottom. So when it's in the bottom, this switch will give a close contact. Close contact means this can start the motor, like it is similar to switching on the motor. This switch on the motor. When the water comes slowly, so then this white color area, what you see, this slowly move up. When it moving up, what will happen? There is inside, there is a micro switch is there that will get activated, and then this will go off. So when the tank level increases, the float goes up. When the float goes up, it will go and activate the micro switch, and then it goes off. And then when the level, when you consume the level, the float will come down, down, down. Once it comes down, it will again switch it on. So that's how the level switch on and off. And this signal will go to the PLC. Close means level is low, and open means level is high. That's how the information passed to the PLC. So basically, like what we understood from this, these devices is these devices send a message to the PLC by close open, like closing the circuit, opening the circuit. So that is how it sends the information to the PLC system. So these are called digital inputs, meaning it can say tank level there or not there, or tank level is low or not low. It can tell only one statement. It cannot tell how much water inside. It can tell wherever you install the level switch, on that location whether water is there or not, yes or no. It's a digitals are 1 or 0. The yes or no is equal to 1 or 0. That's how it transfers. So the digital inputs, or like in other word, like a very simply, if you wanted to keep in mind, the devices which end with a switch, like the text switch, all of them are coming under digital inputs. Anywhere, any switch, all has to be considered as a digital inputs. Right. So basically, all of we understand that the digital inputs gives a signal to the PLC via 1 and 0, which is open and close. That's what we want to understand, whatever the description so far we have seen, right? The digital input. And then we are going to see the digital output. So the devices which operates by on off or open close, those are called as a digital outputs, right? So digital input is from a field, the status are changing and it is giving to the PLC information is what is status. Whereas digital output, like a PLC will say you go on or you go off, you go open or you go close, you light up or light off. So only two states, nothing, no more actually. It's a command. It's a command coming from the PLC system based on your program. What program you wrote, that program will execute and then it gives a command to the field devices, which is the valve, on a valve, motor, and then panel indication lamp. So these three are the only digital outputs in a industrial environment, nothing else, right? So these are all operated by the on off open close command. So we all must be clear now the what is digital input and what is digital output. The difference also should be there. Like a digital inputs are field status going to the PLC and digital outputs are command coming from the PLC in terms of on and off, open and close, light on, light off, two state, 1 or 0, right? Okay. Now, next is like we are going for the analog inputs. So the analog inputs like what is the difference between analog input and digital inputs? So the digital input says in a water tank, it says whether water is there or not. That's it. It cannot tell how much water inside. Whereas the analog inputs, they can say how much water is inside. That is the difference. So that is the analog value. So how it passes the information is, it passes the information in terms of 4 to 20 milliamps or 0 to 10 volt. For example, if the tank level is 0, the transmitter will send a 4 milliamps. And then PLC, you can program it. Whenever the field transmitter gives a 4 milliamps, you can display as a 0% to the operator. And then when the tank level is full, this transmitter will give a value of 20 milliamps. So when the PLC gets 20 milliamps, you can program it. Whenever the PLC receives 20 milliamps, show the value, tank value as 100% to the operator. So now what is happening? The transmitter is understanding the tank level. It is sending, when it is 0, it's sending a 4 milliamps. PLC understand whenever 4 milliamps comes, it shows 0% to the operator. When the tank level slowly increases, if it comes to 50%, then the PLC, the transmitter sends a middle value of 4 to 20 milliamps. And that value comes to the PLC and PLC gets the middle value of 4 to 20 and it shows middle value of 0 to 100%, which is 50%, right? So 50% value is displayed. That is the actual value of the tank. So this is how the analog instrument works. So in a easiest way, if you wanted to keep in mind, we can say any field instruments name ending with a transmitter, right? The field device name end with a transmitter, all of coming under the category of analog inputs because they transmit a signal in terms of 4 to 20 milliamps. Okay, so the difference between the digital input and analog input is digital inputs are they end up with a switch, but whereas the analog inputs end up with the transmitters. That is the analog input. The analog output, there is a small difference between digital outputs and analog outputs. The digital outputs are on and off, only two states, like a motor start, motor stop, and bulb on, bulb off, and then valve off, valve close, valve open. Only two states. It cannot do the regulation. Whereas here, the analog output, what you see here, it's a regulation. You can see here we have a control valve and we have the variable frequency drive. I hope all of you are well aware of the variable frequency drive, because this is your subject, so I'm sure you know well. So basically what they does is like in terms of control valve. See, what you have seen on a digital output is an on-off valve. They go, if you give a power, it goes full open. When you remove the power, it goes full close. Whereas here, control valve, you need to regulate, meaning when you are giving a 4 milliamps, the valve is fully closed. When you give a like a 12 milliamps, which is a 50 percentage, when you give a 12 milliamps, the valve goes to the 50 percentage. When you give a 20 milliamps, the valve goes to the 100 percentage. And you can change it, even 1 percentage also you can change it, right? So that's how you can operate. This is controlled by the analog output card, right? Analog PLC analog output card. From your programming, you can say, hey, I want to open the valve 2%. When you say 2%, then the milliamps coming from the control analog output card is going to be 4 point, maybe like a 0.5 milliamps. There are 4.2 milliamps. Then if you say, I want to open a 10%, then it will be 4.4 milliamps. So kind of milliamps will slowly will increase, so that the valve will respond like a 1 percentage can open. This is analog output. Analog outputs are a command from the PLC, right? It's an analog command, right? Then the same thing like a variable frequency drive. All of you know variable frequency drive is to control the motor speed by controlling the power. The power going to the motor can be controlled by the SCR circuits inside the VFD. Again, this VFD can be controlled by 4 to 20 milliamps. Like by giving the 4 to 20 milliamps to the VFD, the firing angle of the SCR will be varied, so that like the power coming out of this device will be controlled by the motor. So the motor speed can be controlled very well. So when you give 4 milliamps, maybe motor runs in a speed of 100 RPM. When you give a 20 milliamps, maybe it's a 10,000 RPM. So if you give a middle value, it's a maybe like a 50,000 RPM. Like the speed can be varied up and down by using this command, right? So basically, only any PLC, when you say the field IOs, like the input output, two type of inputs are there: digital input and analog input. And two type of output are there: digital output and analog output. When you aware of these four concepts, obviously you can understand the PLC programming concept well, right? So far, like whatever we learned, I can stop now for a 1 minute. I will wait for you. If anybody wants to ask a question, you can ask a question. So the after 1 minute, if nobody asks for question, then I will resume back, right? So I'm going to stop now and wait for 1 minute for anyone asking a question. I got to speaker. Right, guys. So since there was no question, I presume everybody is clear and everybody understand the concept very well. Okay, I am happy everybody understood correctly. So now we'll go for the just have a quick view to recollect everything. So basically, like if you look at here, this is the actual representation of the marshalling panel and field and everything. Like you can see the control valves are there. There is a cable coming. This is like a small cable coming from the field and going to the junction box, and it is connecting into the terminals in the junction box. From the junction box, a big cable is going, because remember, like these two cables are coming, like from a left side there is a one cable coming, right side one cable coming, and it is connecting to the right side. From a left side, this is the termination point where you have the terminal blocks, like is a connector, is a simple connector. It connects, and to avoid a multiple cable bringing into the control room, a big cable, one cable having a multiple wires inside, will come directly from the junction box to the marshalling panel, what you see here. And here it will terminate everywhere, like say it will go like a right, two wires, right, two control wires. Like here, when the cable comes here, it goes into two different location, and from here the multiple cable goes here and connect to the cards. So what you see here, this is what the IO cards, like the small one, what you see here, the black one, all of them are the IO cards, like input output cards. The left side, what you see is a CPU, right? The black one, what you see is a CPU, and this is the small one, what you see, it's a input output card. The input will go to the input, output will go to the output. Like for example, if it's a digital input pressure switch, then that will go to the digital input card. And if it is like the motor, like then it will go to the output card, because it's a output device. So only we should understand what is the field instruments, like whether it is a digital inputs, digital outputs, analog input or analog output. If you are unable to differentiate what is what, then you will not be able to know where to connect what, because you cannot connect the motor to the digital input, and you cannot connect the level switch to the digital output card, because it's like then if you connect, so then you will damage the cards, because like it will go different voltage level will go, and it will destroy the IO cards. So you have to be a little careful, like what type of inputs, like whether it is a analog input or analog output, and also what type of output, digital input or digital output. You have to understand correctly, and then that signal has to go to that specific card. Like a digital input means digital input card. Digital output means digital output card. It has to go. It should not be going to the other way around. If it is happened, then there will be a failure in the IO cards. So that's how we have to be a little careful. So this is to show you, practically show you in industry how exactly the wirings and how the PLC in a practical way it looks. Right? This is how it looks. Okay, this is one of the make. So the look and feel of the PLC may differ from vendor to vendor. Some vendor they give like a black color, some vendor they give a white color. So different supplier has got a different colors and everything. So but the concept is same, like the from a field junction box is sure everywhere you will see, and from there marshalling panel, it is sure everywhere marshalling panel, and then you will see that cable coming to the input output cards. These are all sure, everything is sure. Only the product colors and product dimension, it varies based on the supplier to supplier. Otherwise, like basic concept remains same, right? So we are not going to see the all the different things. So I hope the basic concepts are clear now. And if you are clear about the basic concept, then we can try to see how exactly the programming part can be proceeded. Right now, I presume all of you have the computer, right? If you do not have it, yes, as I said, you can approach for the help and you can get it. So whoever has got the computer, you can follow me to download the software. So what you can do is like open a Google, right? So this software, it won't work on the in your mobile phone. It won't work because it needs an installation. So but it is not a big file, it's a small file, but still it won't work on the mobile phones. It will work only on the computer. So just open the browser. So in the browser you type in SSK DESIGN. Okay, so SSK DESIGN, right? It's SSK design. After typing the SSK design, you click on the enter. I'm going to click on my enter. Yes. Once I do so, so I am seeing the SSK design coming up. So this is how I hope. Okay, it may come. Everyone will have a different window or whatever. So anyone whichever you see SSK design, whatever, you can click on it. Right? I'm going to click on the SSK design. I clicked on it. So once I click on this, a website opens from where you can download your programming software, right? So now in this menu, you can go to the right side. If you go download, there is a download tab is there. You can move your cursor to the download, and then you can slowly come down, and there is a tab called software, right? So you can click on the software. I'm going to click on the software. So I clicked on the software. Doing so, it will show this page. In this page, you can see multiple software for your testing or even for industrial environment. Some softwares are put for easy, quick access. So now, what you can do is like you can try to download the first one, the XLogic Soft PLC programming software with simulation enabled, right? So not on the text. Don't put a cursor on the text. You have to put your mouse on the downward arrow. So you put the downward, you click on it. So once you click on it, so I'm going to click on now. So once I click on it, it will try to download. See, like it is trying to download XLogic Soft Setup.rar, right? So and then save it. So once you do so, like this is not a big file. It is something hardly like a 16 MB or something like a 20 MB approximately. So it will download very quickly. So it won't take much time. That is based on your connection. If you have a faster connection, maybe it is faster. Maybe if it is like normal, the old type, like not a fiber optic. With a fiber optic connection, it would have been very fast. Normal, then maybe a little take time, and then it would have come now. So I presume all of you downloaded. Whoever has the laptop, you would have downloaded. Now I will let you know how to install this software in your laptop, right? Right. After you download, generally it goes to the download tab based on how you configure. So if you click on download, you will see what is downloaded. So so I'm going to install the software. Okay, you click on here, you go to the download where you have done, right? So this is my software. You would have got like this, XLogic Soft Setup.rar, right? So in case like if you are unable to like I'm trying to do now, I'm going to double click on this. Once I do a double click, it open up this window, and it is saying like a purchase WinRAR. Okay, you can close it. If you have not installed WinRAR, right? Maybe it won't open. It will say I cannot open. So what you can do, you can install the WinRAR. Like it's a free software only. You can go to the Google. So I'm going to the Google and say WinRAR. See, WinRAR download. When you click on WinRAR download, this is the WinRAR. Like you can see the right side, there is some books where tied up with a belt because it's zip and put there. So in case you go there and you click on download and you install the software, then that is a very small software, 3.2 MB only. It's not a big software. If you install, then after doing that, you can try to open the same software like which we downloaded from the website XLogicsoft. So I'm going to open it. Yes, I open the software now. Now the software is visible to me, right? So now how do we install it? So just okay, in case if you did not get through, yes, you can do it later, but now I will install. You can follow me so that you can implement, right? In case if you do not get through, you can ask me, or you can call who has done successfully, so that like you all can fix yourself, right? So I'm going to do the setup. I'm going to right click, double click on it. Once you double click on it, it will ask for something like yes or no. Say yes. Then it will ask for like the language. What's this? Yeah. So it's asking for the language. So you can leave it default English and say OK. So then it'll ask for a welcome page and say next. The installation is very simple. Just you need to click next. I accept the agreement and click on next. And this is asking for where do I install the location. You can leave default, or if you wish you can change the location. I will leave default. Go to next. I'm asking for the name of it. If you want to change name, you can change it. I will leave default. Okay, if you want to create a desktop icon, you can create. So the icon comes on there. Say I have a tick mark and say next, and then install. So now it is trying to install. It has finished the installation and asking for the final confirmation. So I'm going to say next, and now the tick mark is there. It will open up the software if you wish. If you remove and say okay, it won't open up. You have to open. So let me open it and say okay, right. So since I said this, you can see it has opened the software. You can see like in the bottom it has opened it. So this is how the basic PLC programming looks. I am not sure how many of you followed this, how many of you get through. So it's not a problem if you did not get through. It's not an issue. We have a time. Maybe like what we can do now. Its time is like 12:10. After a 20 minutes, we will break for like we'll break the time. We'll go for lunch. Maybe like we can come after like maybe 1:30 or 2 o'clock. We can fix a time, and by the time in the meantime you can work out. Make sure you are able to download. You can talk to somebody who did already, or you can call me also. That's not a problem. Somehow you can try to download and install the software, and if the software is available, then maybe by after 2 o'clock we will be starting the programming. That's how we are going to do. So now still we continue for next 20 minutes. After 12:30 we continue. Just we'll have a little review on this, so that like By the time when you get ready, we will start ready all the test. Right. So I have downloaded the software. So software is available with me. When I look, if I look at the your subjects, so far whatever we have seen, it is a just introduction, just review of what we have learned in the previous training. The basics only we learned, basics of what is PLC and why the PLC is used and where it is used and what is the type of input outputs, and then the architecture, and then now we ended up in the programming software. Right? You have to know all the basic before we try doing any the programming part, because the programming part once you come here, the basics are not clear. You may not be understand what is the when do I need to take the input, when do I need to connect the output. That's all will be in a little confusion actually. So you have to know it, right? So now I'm trying to go through the your the syllabus. If you see the syllabus, the first one is like it's a bit instructions, bit instruction and OR gate. I think that's, let me check. Let me have the quick. Right. So in my desktop, just I open the syllabus. So what I've seen is like mathematical instructions, addition instruction, subtraction instruction, multiplication, division, so kind of mathematical calculations. And then we have the bit instructions like AND gate, OR gate, NOT gate, and then the XOR gate, XNOR gate, NAND gate. So basically a gate we are seeing. So the first one is the mathematical operations. Next one is the bit level operations, and then the advanced instructions like a less than or equal, not equal, and equal, this kind of instructions. And then we have the timers, like on delay timer, off delay timers, and then we have the counters, up counter, down counters, and then finally we have the sequencer and the shift register instructions. So this is the quick brief of the our syllabus, what we are trying to cover up during this training. So basically what we are trying to do is now, before we go into the mathematical instruction, we wish to go by the bit level instructions, because what's happening like after a bit level instruction we slowly go into the mathematical. Technically speaking, like the order can be like a bit level logic operations, and then we go for the timers and counters, and then we come to the mathematical operations and advanced instructions, and then finally the sequencer and everything, right? So now the initial subject is we'll be going for the bit logic instructions. So the bit logic, by the word itself, is a bit level operations, meaning like a 1010. How to deal with the 1010? All of you aware that the gates. I'm sure all of you aware the AND gate, OR gate, NOR gate. Those gates are you well aware of it. Like for example, if I wanted to know, for example, let us take a one gate and gate. Right. So basically, like the AND gate, what you see here, like let me open it bigger. Right. So this one, the right side, what you see here, that is the AND gate. That's the AND gate symbol. So so the AND gate is like we have got the two inputs, A and B. Like A and B is a two input, and output is Y. So AND gate generally represented by multiplication of inputs. That is the representation. So Y is equal to A into A multiplied by B. So now when in the inputs, when my first input is 0 and second input is 0, 0 multiplied by 0, the output is going to be 0. And then the second one is the input is first input is 0, second input is 1, 1 multiplied by 0 is 0 again. So finally, like first one is 1 and second one is 0, still 0. And when both inputs are 1, and then 1 by 1 is equal to multiply, you get a 1. That's how the AND gate works, right? Fine. So now what we wanted to use it, we wanted to visualize this, how exactly it is inside. First we will visualize the theoretical way, and then we go for a practical way, right? So let us try to understand the theoretical part correctly by the program. The program, like if you wanted to make the new program, what you're supposed to do is like you can click on this arrow mark. Once you click on that arrow mark, you can see function block diagram, right? It's a function block diagram. Click on this function block diagram. So it's asked for the window. So I'm not going to give anything. I'll say okay, because it's just my testing only. I'm not developing a project. So right. So now this window, whatever you see here, you can see a new word has come, X logic 1. It's a page number 1. In this page, you can build whatever the logic and you can test it. So what we wanted to try is, whatever we learned as of now, the AND gate, how it functions, we can simulate and test it. Right. If I go here left side, under a basic, I can see there is an AND gate, right? You just click on it one time in your mouse. You can click one time. Once you click, the AND gate will attach to your mouse. Even if I move this side, you can see here nearby my cursor, there is AND gate is attached, because I clicked on it, it is copied, and copied it is available for me. And then if I need to paste anywhere, just I need to click one time. So I'm going to click one time. I clicked, right? So still it is, if you see the cursor, I have available. So if you want to make another AND gate, I can click. So as many I want, I can keep click. Then how do I come out from this? So you need to press escape. If you press escape, then whatever the attachment will detached. It will go away. So I'm going to click on the escape now. I clicked on the escape. Since I clicked on it, that small attachment is gone. So even if I click anywhere, I'm trying to click somewhere, but nothing is coming up because that attachment is gone. Right. So I am trying to try only this one gate. I want to try. Right. If you see here, the example, whatever the internet, what we have seen only the 2 input, but here we are seeing a 4 input. By default, it gives a 4 legs, but you can use, that is up to you how you want to use. You can use a 2 leg, you can use a 3 leg, you can use a 4 leg. Whatever the leg you want, you can use it. But ultimate logic is again, output is equal to multiplication of inputs. That's what the AND gate output. Right. So what we do now is like we are going to simulate the input and see the output, how exactly it works. In order to do the simulation, I need inputs, right? I cannot write a value on the wire itself, right? I want an input. I want to create an input here. So what I do is here, I go to the top, very first page. So remember, like we have seen digital inputs and analog, digital input output, analog input output. Right? You can see digital, under digital, we have a input, we have output. The remaining you can leave it. We will see it later likely. So input we have, output we have under digital. So digital input, output we have. The same way under analog, we have a analog input and analog output. So we have analog input, analog output under analog, digital input, digital output under digital. So input at least, right? Right. So basically, like the left side of the gates are input, right side of the gate are output. Because left side of the gate is an input, it takes and evaluate, and then it gives the out result. So this is the actual conditions, and this is the result. So this is the input, this is the output. So now I'm going to take a one input, the same concept, click one time. Once you click, if you move your cursor, you can see along with the cursor there is a input connected. So I'm going to click on here, my first input. Still, if you see here, the cursor has got that small portion attached. That is my next input. I can connect, I can click how many I want actually. So I want to just with two inputs, right? So if I wanted to detach my the pickup, then the same concept to be formed, escape. So I need to click on escape. So I did a escape now. So now we want to test the result output. So because this is the input side and that is the output side. So I want to take a output Q. This is the output. Once I click on it, the same concept, it attached to the mouse. You can see something's attached to my mouse. So I'm going to click on here. Once I click, the output has come. Still it is there. You can click as many as output you need. But in our case, we need only one output for testing. So I'm going to click on a escape. Once I click escape, it's gone. Now you can see the symbol I is the input. If you bring your cursor, it shows input. I is the input. If you bring the output Q, is the Q is the output, right? So I is the input, Q is the output. Now, how do you do the wiring? So how to connect it? That is what we want to know now. How to connect this all of them to test it. So basically, what you do, you can come to the left extreme, like the third one. If there is an arrow is there, connect or press F5. That's what they're saying. You can press F5 or connect. Right. So I'm going to take it by symbol. I am going to click on it. So once I click on it, you can see that wire is attached. The same concept, like once you click, the wire is attached. The attached wire, you need to use it. So what you can bring it to the any input. Once you bring the input nearby, there is a blue color box comes, and also the chain comes. That means that is a connecting point. If I bring it to some other place, it won't come. It will show only the connector, but it don't show the blue with a chain symbol because there is no connection available. So again, I'm going to this step. So I am seeing the chain symbol with the blue. So what you can do, you can click on your mouse. See, when you click on your mouse, you can see the blue comes there. Click and hold. You should not leave your click, right? Don't leave the click. So and then you move your mouse. So like see, it is attached, and then it is coming to the next end. So now you come to the very near point where again the chain comes. You can see here the chain coming up. The chain has come up. Once the chain comes up, you have to leave your click. And click your leave here. Once you leave it, it will get connect. Right? So I'm going to do the next one. So I'm going here. I got the chain link. You click and hold again. I click and hold. Now moving my mouse with holding. I need to keep holding, and only I need to move it. So connect any one of the leg. It is not necessary you have to connect 1 and 2. any one of the leg, two leg. Right. I finished with the wiring between the input and AND gate. Right. Now, this is the output. This is AND gate, AND symbol, right? This is AND symbol. And when I'm bringing the mouse, it's showing me AND also. The same concept. You can click, you can bring here. Again, you are seeing the blue color with a chain. So I can click and hold it, and then drag to the output until the chain comes. Once the chain comes, you leave it. That's it. So the program what we have done is, like, now if I need to the remove the attachment of my wire from my mouse, click on escape. So now what is happening? Now I completed my AND gate logic, right? So now I wanted to see how this is responding. Is it the way how we have seen the internet? Is it the way how we learned in the college syllabus, right? In order to test the simulation functionality, what you need to do, you need to go to the tools, right? In the tools, there is a the word like a simulation. Either you can press F3 or you can come here and click on this simulation. Right. So I'm going to click on this simulation now. Once I do so, you can see in the bottom there is a controller comes up. Slowly, like what you can do, you hold this cursor and move it up. Right. So this one, like just below the, just above this bottom, there is a small separator is there. At that separator, you click and move it up. So I moved up, right? So now what is happening, like this is what the exact PLC we are going to do the simulation purpose. The top, what you see, all of them are inputs. I1, I2, I3, I4, I5, I6, I7, I8. This is the address. And then the bottom, what you see, all the digital outputs like a Q1, Q2, Q3, Q4. These are all the digital outputs. So top, what you see is a digital input. Bottom, what you see is the digital output. Right. So now the blue color, what you see, the moment when you see a blue color, that means is off. Off means there is a 0. When you see a red color is on, the value is 1. That's the difference, like on and off. On means red on, 1. Off means blue, 0. That's what the meaning is. Right? So now I'm trying to switch it on the first one. If I need to switch it on, what should I do? Like you simply double click on it. Right? Even single click okay, right? So just one click, it will come. Like for example, like I'm going to click on the first one. I clicked one, on has come. If you look at here in the I1, the red has come. That means basically it is simulating the input. Though you do not have the physical hardware, by doing this, it simulates the input. The input has come. The input has come. You see this Q1, like an address, like you can see the address, huh? I1. You can see I001. This I001 is nothing but I1 because zeros are do not have a value. So I001. Like what is I002? So when I make this on, you can see the I2 coming up on because this address is I2. So I'm going to do a simulation. So as of now, as the actual the equation, like and the gate 1 into 0, like now the top one is 1, bottom is 0. 1 into 0 is a 0. That's what it is giving. That's why it's off Q001, which is a Q1. The bottom you can see, this is the Q1. Right. So let us do the simulation now. So I'm going to do the simulation of the input 2. So I clicked one time. So this has become a red color. It's become on. And you can see the input also become on, red color. So 2 red has come and once the two red comes, you can see the bottom Q1 is closed. See Q2, look at the Q2, it's open contact. There is, it is open, means like a, it's a kind of like a switch on, not switched on. By using this, you can switch on the motor and everything, you can use it. This is the physical hardware, what is the bottom. The physical hardware, now it is simulating the simulating for you to visualize how exactly it looks in a real condition, real scenario, right? So now if I make the keep the bottom one is on and top one is off, the same case like a 0 into 1, and when both are 0, obviously off. So when only the output goes high only when both are 1, which is usually AND gate, right? So far, like whatever we learned is a initial touch up for the programming software, and how to download, how to install, and what is the initial the PLC and everything we learned. So now we will break now. So whoever did not finish the installation, who need a help, you can call me or you can call somebody else, your friends or whatever, who get through and try to install. And whoever do not have a computer, you see a possibility of getting it, or you go nearby your friends and get ready for the 2 o'clock. So after your lunchtime, 2 o'clock, we start with the rest of the configurations, how we do the configuration, as well as the examples, like the practical examples. What we see right now is a theory pattern, visualizing. Only we are visualizing whatever we learned. Is it really happening in the real world? That's it. But we are not doing building our own logic for any industrial application. So we, after doing this test, everything understand clearly, then we choose the industrial application. Let us try to build and try to visualize, and maybe you can send me the print screen of whatever you get through, so that will make sure that you understand correctly. And if you did not understand, you have a you can always ask me, we can brief it, right? Okay, now we'll break now, and we will meet after, I mean, like by 2, exactly by 2 o'clock we start. And as we said, like, you try your level best to get it working system. Okay, I'll break now, and if anybody wants to call me, you can call me and I can reply to you. Okay, see you after 2 o'clock. ಏನು ಹೋದ್ಮೇಲೆ ఎవరిని ఇల్లండి సార్ లాగ్ పెట్టండి వేరే వేరే లేదని ఎవరిని ಇಲ್ಲ అయ్యో Mm. Right, guys. So looks to be like, see, now almost like a 2-8. Like we proceed with this and let the people join and they can continue. So let us not waste time. So yes, let me share my screen. Right. Right. So far, like what we have seen is like a very simple AND gate we have seen. So the AND gate, like we had the two input I1 and I2, and then we had the AND gate. So as and when we activate, when both are one, so we are getting the output. So any one is zero, so we are not getting the output. That's what the actual AND gate, and we visualized, and it is okay. Right. So we do not go with any the examples, the process examples. Like just we will try to visualize all the gates. Right. So now, if I wanted to go break the, like now in this situation with the simulation, if I am like when I click on the AND gate and when I try to bring in, it won't come because like right now I am in a simulation mode. So when you are in a simulation mode, it won't come. Okay, so let me check the, okay, so when it is in the simulation mode, um, the gates or any other inputs or outputs, it won't follow your cursor. So what you're supposed to do, you need to break it. So in order to break the simulation mode, what you do is like you go to the same tool, and then you need to click one time the simulation. So once you click on this simulation, then you will see the color on the line goes off, and then it comes into the configuration mode. So that is a run mode. This is a configuration mode. So in a configuration mode, you can configure, but you cannot test it. In a run mode, you can test it, but you cannot configure. That's what the actual thing. So now, before we go to the next gate, we can try to see three inputs, how exactly it works, right? So now, if I want to pick up the third one, I can click on the input, right? And then it got attached to it. And then I click on here. So I got the third input. So third input, like once I get it, as you all know, the wiring is like you need to pick up the wiring from here. So click on the wiring, or you can press the F5. Both are same. So then you can bring your cursor nearby this connector, which is the chain, and then hold the your mouse, and then you drag it, and then come nearby the connector, and then leave it. Right. So that's how it is connected. Now you can see the three inputs are connected. So the function is same, like either it's a 2 input or 3 input or 4 input. So it's going to be like a multiplication. When all of them are 1, you get the output. Otherwise, you get the 0. Right. Let us try to simulate. So right now, still the connector is attached to my mouse. That's why you see there is a small arrow in it. So I can remove it by pressing the escape. So yes, it has gone. So now what you can do, like you can click on the tools and go for a simulation. Right. So now if you see, like we can see the controller also, just for right. So not here. Right. So you can see 2 inputs are on, but still the output is off. So if I make the third one on, then you can visualize the output coming up. So basically now 3 inputs has to go high in order to get the output on. Right. So in the brief, AND gate is like a multiplication of all 1, and that's what it gives. So now not only we understand the gate, we understand how to connect the inputs and how to connect the outputs. Okay. So all the inputs can be like one can be a pressure switch, one can be a level switch, one can be a your toggle switch, and then the output can be motor, anything it can be. So right now, like with a simple implementation, at least we understand how to interact with the physical portion. Like right now, with this block, with this specific address I001, with this specific address, I could access my physical IO. So in the physical IO, if I do the wiring, and if my wire goes high, when switch closes, I get this input coming up, and then the logic executes. Whereas now I'm doing a simulation, so as if the input is coming, right? Right. So the AND gate is okay. If you have any question, you can ask me, because see, everywhere like the clarity is very important. If you have any question, you can ask me now. I can hold for next 1 minute from now, and if you have a question, you can ask me. I could see only 8 people joined. It's very less people. Okay. Right. So it looks to be there is no question from you. So I presume everybody understand this correctly. All right. Fine. So far what we understood is like the OR gate we learned, the AND gate we learned, and let us check the OR gate now. How to implement the OR gate. The input method is same. Like for example, like how to attach the input, it is okay. So in order to go for a configuration mode, you have to break. See, I'm trying to move my block. The block is not moving because like I am in a configuration mode. Actually. So I need to go to and remove the simulation. Once I remove the simulation, now I am in a configuration mode. So now if I try to drag it, yes, it will move. So this is the input 1, this is the input 3, and this is my input 2. So now I wanted to try with the OR gate how exactly that works, right? So in order to get the OR gate, the same way you can scroll down and you can pick up the OR gate. You click on it, and then you bring into the working area. You click on here. That's it. So now you got the block coming up. So now, so basically what we have to do, you have to connect the same input. Like just for your information, the same input can go to the any number of logic, right? One input can go to any number of logic, but whereas the output can connect only one time. So for example, like I'm going to connect the another output number 2, right? Output number 2. So I'm going to connect it again. I take the wire and connect it here. Now this is my output to Q002. This is a Q001. So if we look at the actual the PLC hardware, you can see Q1. This is Q2. Now we are programming for the OR gate. We are programming for Q2. We already programmed AND gate for Q1. Now we are programming for Q2 just to see the output how it is coming, right? So now we have taken the OR gate and we have given to the output 2. So now it is not necessary we need to bring the one more block. The same, the I1, you can take the wire and you can connect it here, right? And the same wire I3, if you want, you can connect it. You can connect it to any of the input, right? So now if you look at there, the input 1 and the input 3, the input 1 and input 3 connected both AND gate and OR gate. So as a OR gate is like a plus B. Any one OR gate, any one. In AND gate, all supposed to be there, but in the OR gate, any one, if it is high, the output goes high, right? So now we connected the 2 inputs to the OR gate, and then whenever these 2 input, any one of the input becomes high, we want to activate the one of the output Q002, right? So now this is the OR gate implementation, and let us check how exactly this is going to work, right? So I'm clicking on the simulation again. So if you look at there, you can see the screen as well, just to visualize the physical hardware, how it is. I will move the okay, slightly I will move up. I will go configuration. I will slightly move it up because I have a less space, so I wanted to move it. I will move it up to top, right? So now I can move it up here, right? So we have enough space now to visualize everything. So I'll go for tools and simulation, right? So I have slightly right. You can see now, right? So what we have is like we have only one input is high. You can see I1 is high. I1 is high. You can see the output 2 Q2 is right now it is closed. The contact is closed. That means like if you connect any of the motor, it will start immediately by now. Even with the one input high, the output becomes high, the motor starts. Whereas the other one, Q1, it's AND gate, all has to go high. So now, if anyone, all of them are goes low because A plus B. So now 0 plus 0 is 0, so goes off. So again, with the same another leg, even with the one leg of I3 is on, and you can see Q2 is on. The second output will become energized. It's closed, so it can start the motor. And whereas the first one still it is off because it is expecting all 3 has to come because it's a AND gate, right? So this is the OR gate, how exactly it works by nature, by default, how it works, right? So now we understand clearly the AND gate and OR gate. Now we want to understand one more gate. It's a set reset flip flop. Set reset flip flop we will understand one time, and once we understand the set reset flip flop with the combination of set reset flip flop AND gate OR gate, we can see multiple logic, multiple process examples, like a practical, like whatever you learned is you already know it, Because AND gate, you know it, OR gate, you know it. It's not something magic new. Already you knew it, but only thing is, with this example, you understand the AND gate implementation and how to connect it to the inputs and how to connect it to the outputs. What is input 1 and what is input 3? How exactly in the PLC configuration, how exactly you connect it? Like a wire comes, where do you connect actually? Like for input 1, I used to connect on I1. The wire comes from the switch. I'll bring the wire and connect it here. And I2, if it is like a level switch, from the level switch, I'll bring one wire and put it here actually. And that's how I connect it actually. And here in the motor, I will connect the output to the motor. So at least we understand that how the physical interaction, physical hardware, how it connects to the whatever we know already, the AND gate, OR gate, how we connect and how we take the input output. Right? That's what we understood so far. Right. So now again one more theoretical example, just to visualize. We want to try for the set reset flip flop. For example, when I push the input 1, I want to set the output, right? Like in your house, how you operate, like in your house you have the motor available. So generally the motor, what you do, some people they have a like they used to toggle switch, just make it on, it will be running, and make it off, it will go off. This some people they have this kind of arrangement, and some people you have maybe like push buttons, like you have the green color push button and red color push button. So when you push the green color push button, it has to start. When you push the red color push button, it has to go off. That's what you do it actually. So that is like a set reset flip flop concept. So now that is what we wanted to learn now. Assume that the first input is like a green color push button, and second could be the red color push button. So when I push the first one, it has to go on. Second one, when I push it, it goes to go off. So that's how like you operate in your home, how you operate. Let us see how exactly people have implemented by using the set reset flip flop, right? So to take the set reset flip flop, again the same concept. You need to remove the simulation. If you don't remove the simulation, it won't allow to add anything. So remove the simulation. Once I remove the simulation, yes, now you can add it. So I'm coming down. I'm trying to pick up the set reset flip flop. So I come down, and then here, this is the RS flip flop. Like you can see the symbol RS, right? It's a latching relay. So you click on once. Once you click on it, it will attach to your mouse. So I got my latching relay on my mouse. So you can click where you want. So I'm clicking here. So I got this. So I don't want any further same block. So in order to detach the blocks attached to my cursor, I have to push on escape. When I say escape, yes, it broken the link. So now I'm going to do the wiring. So now if I bring my my cursor nearby the leg, it is showing me the first one is set. That means this is a set. Whenever I'm making a 1 here, it will set. So now when I come down, if I bring it down, it is a reset. So whenever I make it this high, it goes reset. So the top one is set and the bottom one is reset. That's how it operates actually. So now assume that whenever I push the input 1, I want to set the output, and whenever my I3 is pressed, I want to set my output to 0. Now I want to connect my the physical output, this time Q4. I want to connect my Q4, which is the fourth output. I want to connect it. So what I do is like I can go here or copy paste. Anything is possible. So I'm going to this the the palette, and I'm taking the output and I'm bringing here. It got pasted with my mouse, and I'm clicking one time and say escape. I said to you that I want to connect this Q to my Q4, but if I see the top, it is showing Q3. How do I change this to Q3 to Q4? Because I want to set the output Q4. So double click on this. When you do it, this will show what is your input. So you used already Q1, Q2. So you unused is Q3 and Q4 is unused. So you can choose the Q4 and say OK, right? So now Q4 is available for you to connect it to the set reset flip flop, right? So now let us use the wire to connect those input outputs. Like I'm going to click on this. I clicked on here and then my cursor picked up the wiring from the palette, and now the same thing I bring here and I'm clicking on it, holding it and bringing it to this nearby. It's got latched. So now I connected the set reset flip flop output to the output 4 actually. Right now I want to use this one. Whenever I make this one on, I want to set the output high. If I want to see this wiring, if you want to, like they say, it is getting confused, hey, we don't know where it's coming. So what you can select it, and then the red portion, you click on it, you can drag it. So that way it will move the line, and then it will give a better clear lines, right? In case if the lines are not clarity, you can move it wherever you want, right? So now I wrote a program that when I push this one time push on, it will go set actually. When do I want to reset? So I plan to reset by Q3. So whenever I click on input 3, I wanted to reset. That's my requirement, right? So now this is what the my logic is too, right? So just for better clarity, I will bring it down, right? So if you look at the screen, I001 is there. It is saying whenever the I001 goes high, then my set will come here and then it will activate and the relay will latch. Even my input goes 0, it will be latched. That's what the latch relay function. Once it says latch means it's latch, it's hold actually. Though the input goes 0, it hold the last input actually, and then it will wait. The output goes low only when it gets the input 2. The means which is a reset goes high. Otherwise, it remains the same actually, right? So now, what I'm going to do is like now I'm going to simulate now to visualize the actual output. So the same philosophy. We'll go to the tools, click on the simulation. So now we are at the simulation, right? So I want to make it off. All of them are off. Now everything is off. Q4 is off, and all the inputs are also off. So as we discussed, if I make one time the input on, it will go and set the output. Like let me try now. So I'm going to make it on. When I make it on, the Q2 and Q4 become on. Q4 is becoming on because of the set reset flip flop, and Q2 is on because of the OR gate, because one of the leg is high. That's why it's coming. Now, as we discussed, even if I make it off, the set reset flip flop output should remain in on condition. That is the set reset flip flop. So I'm making on. So you can see the OR gate output, which is a Q2, is gone low, whereas the Q4 is still on because it is latched. So it is latched. It is latched high, right? So this can go low only when we give the input on the reset. When you give an input on a reset, it will reset. So I'm going to do the push this. So I pushed it. Once I pushed it, you can see the Q4 is gone off, and you can see the physical hardware Q4 is gone off, right? So this is how it operates. Like the set reset flip flop in the set leg, when you give a one time, if you give a 1, it sets and remain the high until the other input comes, right? So now, as we understand, like see, we understood that we understand AND gate well, OR gate well, and set reset flip flop well, right? So now with this examples, let us try to do a one process example, how to implement and achieve it. Right? So I will go through with a one process example to make you clear understanding, and maybe I will ask you to do. I will give you one. I will explain one process. I will do it and simulate and show you. With a small change in the process, I will ask you, and you can implement, and you can send me the print screen to me, so that like a you can post it here. Actually, you can post either on a WhatsApp. You can post it, because you all of you know my number, so you can post it there, or you can post on the Teams itself. I think Teams also can accept the. I'm not sure whether it can accept or not. Let me try. Let me try this. I'm going to try now. I will say. Um, looks to be not possible on the Teams. See, paste, not paste. Okay, I think then you can share it on my WhatsApp. Like my WhatsApp number, I hope everybody knows, but still, who do not know, I can share it. 9840292883. It's my number. So I shared on your the Teams text. And you can see the Teams messages. I put my the WhatsApp number. You can add it. So whoever has done it, whoever has finished it, maybe you can take a print screen and send it to me when we give examples, right? So that will show that how exactly we are understanding, how we are progressing, right? Now let us go ahead with our process explanation and see. Right. So let us take a small example. Right. So this is the example which we are trying to do now. See, the same AND gate, OR gate, set reset flip flop. Only we are going to use it. So, but when it comes to the practical, only thing is you need to understand how to convert the practical information into the gates. That is what like you supposed to know. Once you know that, then the remaining everything is very simple. So so now let us try to understand this concept, and then we will I will try to work on this, and let us visualize this. So basically what it says is like when I push this start, like when I push the start, green color one, when I push it start, the motor here should start. So push and release. I don't keep it always high. Push and release. When I'm pushing, this gives a 1. When I'm releasing it, it gives a 0. Right? Push 1, release 0. The motor has to start. And then I have another input, second input. This is the first input. This is the second input. So this is connected on I001, and this is connected on I002. So when I push this, assume that it gives a 0. See, it is reversed. Slightly, you notice it carefully. When I push this, it gives a 1. and when I release it, it gives a 0. When I push this, it gives a 0, and when I release it, it gives a 1. But my requirement is like when I push this start button, when I release it, it has to go start. And then when I push this and release it, it has to go off. Right? Take a note. When it is pushed, it gives a 0, but this will give a 1. Just slightly reversed. This can happen like this is based on a device, how it is configured in a field. Sometimes some switches will give a 1 when it is activated. Sometimes some switch will give a 0 when they are activated. So there's a small difference between the different devices, right? And then we have the other one like the level switch. So this level switch, when the level is low, that means there is no water. When there is no water, it gives a 0, right? No water, 0. When the level slightly goes up above the switch, that means like it's a required level, then it gives a 1, right? So the process logic is like whenever the operator starts the motor, it has to start. Whenever the operator stop, it has to stop. In case if the operator is given a start, for example, motor is running, and he left the plant for some reason, like he left the plant, and the level in this slowly will come down, come down, come down, come down. When it comes, there is no water. Though he is not there, he is unable to stop it. The switch will take care of that. It will stop the motor. If it don't stop, what will happen? The motor will run dry running because there is no water. The motor will get slowly heated up, and then after some time, the motor coil will burn out, and then you ended up in a lot of loss. So this switch in this application, it is to protect the dry running of the motor, so that when there is no level, the pump will be stopped, not to run the plant, not to lose the pump because of the coil damage. That is the whole process requirement. So basically, we need to understand very clearly basic process requirement. Process only when you go to any plant. Being a system engineer, they will tell you the requirement. They will tell, I want, when I push start, it has to start. Nobody will tell you put a AND gate and then you put a set flip flop. Nobody will tell you. They will tell only the requirement in terms of wording. Like when I am pushing a start, it has to start. When I am pushing a stop, it has to stop. But in case if I am given a start, and if I am not stopping, but if the level is less than the level switch, then the motor has to go off. So this is my requirement. You please write a logic and implement everything. That's what the statement only they say, right? They don't say like AND gate, OR gate. Hey, you put a AND gate for shift flip flop for the start stop, and then you put a AND gate now, and then connect it parallelly series. No, nothing. Nobody will guide actually. So we need to understand, and we need to convert that into the logic, right? So now we all of us understand the process requirement. What is the required? So now we are going to achieve this. So what I said is like just for understanding, we will write here in the start is a I001. That's what we said, right? And then stop is I002. And then the motor, the command is we'll take this one just for a better clarity. I'm writing it so that like we don't lose it. Q001. This is my output, which is going to drive the motor. So this is my Q001 connected to the Q001 PLC, and this is my input 1 connected to the I001, and this is my input 2 connected to the I002, right? So with this and also like the other one is this one, like the switch. This level switch is connected to the, let us say I003. So these are the address. Basically, this is the IO address. IO address. Okay. I will say here also IO address. Keep here. Keep it here. IO address. So we have a start address, we have a stop address, and we have the actual motor command Q001, and then we have a level switch address also we have. Right. So now we understood the process concept very well, but now we'll try to implement it in the program. So now I want to go to the normal mode, because like right now in a simulation mode, I will remove the tick mark. The moment when you see blue color or red color, that means it is in a simulation mode. So you have to go to the normal mode. So I will remove all the logics, all the blocks. I removed everything. Right. So now what we want, like we want like a input 1. Okay, input 1. What they said, like this input. It is a basically like a what this is a start, right? Start green. Okay, we'll say start green. Right. So you can see start green, I001, right? So the next one is like a I002. See, that's what like a, it is a stop red actually. Stop. This is red. Say red. That's what like see. I'm not telling like myself, and this is what we have given, because IO address 001 is a green color button, and IO 002 is a red color button. This for the text whatever we are putting, this for our understanding only. It is not like a PLC understand. It is only for our understanding. Only I001 can understand by the PLC. But whereas whatever you see the in bracket is for our understanding, for our easy understanding, right? So now we taken the 2 input, and we have one more input also. So I will take the one more input, right? Escape, and then double click on it, and this one I need to give this is a level switch, right? Level switch. Level. So you can say level switch. Right, this is a level switch. And so we have a start button, stop button, and level switch, and we have the digital output also, that is for the motor to start. It's a motor command. So we'll take a digital output Q, and this one what we said is like a motor command, CMD, motor command. The motor command. So now we configured 4 output, like 4 IOs, like we can see. Just to verify, we have the start address I001 green color, stop address 002 red color, and then we have I003 this level switch, and then we have a Q001 this motor, which is a output. Like you should understand very clearly, this is a push button switch. Green color push button switch, red color push button switch. This is a level switch. As we discussed, all switch all supposed to be digital input, and this is a motor. We know that motor is a digital output. That's why Q001, right? So that's why like we need to keep the old information clearly. What is input and what is output? Output inputs are because you are giving information to the PLC that you start it and you stop it, and this is telling stop the motor. So it is telling information to the PLC, and also it has a name of switch. That's why all of them are input, and this one is a pump motor. This needs to go on. PLC has to give a command to the motor to start. That's why it's a digital output. Accordingly, what we have done, we chose the digital output for the motor. All of them are digital input, and we use the digital input block. Right? So we should be clear on concept why we choose the input for the the green color push button, red color push button level switches, because those are switches connected to the PLC. This is the input to the PLC, whereas the motor is an output from the PLC. That is why we are using Q, which is the output, and also the address is based on what we have presumed earlier, right? Now we want to start the motor. That's not the initial thing. So what we said is like push button. When you push and release, it has to keep running. When you push and release red, it has to go off. And then while running, when the level switch low comes, it has to stop. Right? That's what we said. Like. Now let us write a clear definition. Here, what we said is like let us write a small text. There must be some text here. Here. Right. This level switch. Let us write what is level switch, just for better understanding. We'll write here. You can see clearly when level low means 0, level not low means 1. Right. Same thing, copy paste. You can see either you can click on this A arrow, this is like a text, whatever you see, insert comment, or you can say F9 also, or you can copy paste again and again whenever as and when required, right? So it's not necessary like you have to do only one method. You have multiple methods. You can, whatever the method you need, you can try it. Right. So now I need to modify this text. I go to this screen and then copy from here. This is just, it's not necessary you have to do it, but this is just I am bringing for you to visualize better when you do a simulation. So it gives a better clarity on it. Right. And then like we bring it down. So we have one more. I will click on it. Control C copy, Control V paste, and then I'll bring it top. So basically, like when I go here, when pushed it gives a 1, and when you release it gives a 0. That's what we wrote here. We wrote there, so I'm writing it. Right. So what you said is like when you push this, push and release, it has to start. When I push and release the red color, it has to stop. And in case if while running, if this comes low comes, it has to stop. Right. So let us try this, how exactly it works. I'm going to do wiring. So before doing wiring, like I need a block, right? So when you push and release, it has to run means like what exactly you select. You use to select the set reset flip flop, because even when I make it 0, it has to run, right? The moment when you say for the motor, most of the cases they use the relays, like latch relays. Under a miscellaneous, right? Right. So what you can do is like a set. So when I push, I wanted to start this. So when I push, it goes high, and it set it and becomes 1. Right. Now, when I push this, I want to stop it actually. So when I push this, stop it. Let me connect it here actually. So when I push it, what do I get? When I push, I get a 0, not 1. So in this set reset flip flop, in this leg, when I give a 1, that means it's a high, then only the output will go 0. If I'm giving a 0, it won't go 0. Right? So that's what you need to realize very carefully. Where this stop button, when you push, this gives a 0. That's what the definition it has given. That is because if it is a 1 means it's easy to implement. When you push, it will give a 1, easy to implement, because directly you can connect it directly. But it is giving a reversed. When I am pushing, it is giving a 0. It's a reversed. So basically, you need to reverse the action. Already the switch is reversing. You can revert it again by using a NOT gate. I hope you know NOT gate. This NOT gate, the function of the NOT gate is like if I give a 1 here, output becomes 0. If I am giving a 0 here, output becomes 1. So it get invert. So basically what I want to do is like when my input is, when I push a 0, this gives a 0, and then this output will become a 1. When I count the 1, then it will stop the motor. So I achieved my logic. So whenever I'm pushing my start, it gives a 1. So it sets the block and the motor runs. Right. That's clear to me. And then when I push the stop, when I push it, it becomes a 0. And it becomes a 0, this becomes a 1. And when become 1, it stops the motor. Now we have another let us check only this. Let us simulate and see. Let us satisfy ourselves, and then we go for next. Right. So now I'm trying to do the start now. So I'm going to do the start. So I'm making it on now. So I clicked on, means like I'm pushing it. When I'm pushing, it's giving 1, and I'm releasing it, but it is not going on. So it looks to be something is not correct actually. Something is blocking me from starting, because this one, when I do a program, this is coming and it is resetting continuously, right? So this is somehow it is affecting me, is blocking actually. It's blocking from start actually. So some mechanism we have to implement so that I can block it. Let me do the other way around. Let us say I will remove this and do one test. I will take this, connect it. Let me do the simulation again. Right. This looks to be okay, but it is not correct actually. Let us try now. So let us say when I make a high, low, means like a pushed and released. When this is a push, 1 on, release is 0. So when I push and release, till motor is getting on, looks to be okay. And then right now it is off. When I push and release, yes, it will go off. But actually that's not the logic what we asked for. Otherwise, like we can keep the logic itself very simple for you to be clear. Maybe after learning a few examples, then we will reverse it, because the reverse logic is little complex. It may confuse, like I will make simple. Once we learn few examples, then we will go for this one. Okay, time being, assume that when you push the stop button, it gives a 1. When you release, 0. Time being consumed, assume the level switch, when you push, it gives a 1. When the level is low, when the tank level is low, it gives a 1. Is not low means 0. Right. Let us keep this simulation and try once. Okay, as to meet this logic, I am pushing and releasing. I made a 1 time on, then 2 times click, on and off. So it's running. So again, the same thing, like when I push and release, it has to stop. So I am pushing and releasing, stop. It worked correctly for this combination, right? So now we need to add along with this, in case I push and release, I am operator, I pushed and released and gone home. Now when the tank level slowly comes down, once it comes down, it has to stop. That means just you say as a word, either the operator push stop, it has to go off, or the level switch comes, it has to go off. If any one comes, we want to stop the motor. So when any one means, like what is the gate actually? See, for everything means is an AND gate. Any one means OR gate, because if any one is 1, output will come. Everything means like all has to be 1. So in our case, if any one activates, we want to stop it. So basically what we need, we wanted to find out, like put a OR gate, because any one comes, we want to stop it, and that OR gate we want to connect it here, so that if any one is activated, it stops. So by the word, you need to derive what is the gate required. Like what I'm going to do is, like I'm going to delete this, select and delete. bring the OR gate from here. Click here, click escape. So now what I want to do, like either this comes or this is OR gate, right? Or this comes. That is the logic, right? Like when this comes, when operator pushes stop, or when the level becomes low, I want to stop it. So this is what the actual the requirement. So let us check it how exactly the is going to work out. I go for simulation. So now we have everything in lineup. So I'm going to make it a being an operator. I'm going to start now. Click release. So mod is running, right? So being operator, I'm coming and I'm pushing, push and release. Stopped. The motor is stopped. Okay, clear. The motor start stop is working fine. So now operator comes here. He pushed and released. Motor is running and he has gone home, and nobody is there to stop. The level is slowly coming down, coming down. When the level becomes low, it's going to give you a 1. So let us say when the level becomes a 1, also it stops. So now what is happening? Even the operator starts and goes home, the level switch takes care of the motor from running, so that it avoid dry running, it avoid damage of the motor. So pump starts. This they used to say the manual start stop with auto stop, because automatically it stop when the level is low, right? So hope it is clear to everyone. So you take this, you understand this. Now what you can do, the same implementation you can implement on your programming the software, and try to simulate and send me the WhatsApp print screen to see, just to understand how many of you understand this concept well. So this is not only understanding this concept, also how you take the blocks and how you connect it, how you execute. But while you are sending, make sure that you are in a online mode, like a simulation mode, and make it on, like make it on and show me the result. That's on running. Make it on and off. And this whatever I am showing now, this statement you bring it, this situation you bring it, and send me the print screen. You try to make all everything, even including the text also you can make it. So that only will give you some kind of better understanding on the program, how to handle the programming software, right? So make the clear picture, the clear implementation, make a print screen and send it to me, right? So now we will break the class almost like at 3 o'clock now, and but tomorrow 9 o'clock we start, because today being a first day we started little later, and tomorrow we start 9 o'clock, but we will not have any afternoon session, because today we got delayed, that's why this one. And tomorrow morning 9 o'clock we start, and then by something around 12 o'clock we close it, and that's it. That's what the class we approach. Okay, so see, as try as much as possible by you, and try to send a WhatsApp print screen, and let me see how many of you followed correctly, and how many of you have a software installed in your PC. You can always ping me, you can always text me if you want any help. I can assist you, right? Okay, now 3 o'clock we can stop now. If you have any questions, maybe like I can stay here for 1 minute, and you can ask me question with this program in case if you want. Otherwise, like we can close. So from now 1 minute, I will wait for your message or call, whatever. Right. So I presume you all clear about the implementation. It's okay. So we will stop the class now, and we will see you by tomorrow 9 o'clock. And in the meantime, let me see how many of you is going to send me the print screen. Okay. Bye.